Sanitary landfills. In the process of sanitary landfills, the solid waste are dumped into low-lying area on the land and covered with good earth of at least 20 centimeter thickness. This ensures that insects and rodents do not enter the landfill and the refuse is not directly exposed. Each layer is then left for at least 7 days and it is compacted by bulldozers. Insecticides are sprayed on top to prevent breeding of mosquitoes and flies. Now the solid waste eventually stabilizes and within 2 to 12 months the waste settles down by 20% to 40% of its original height. For the first few years there may be some odor, but after that the land can be used for developing parks. Phases of sanitary landfill. The waste deposited in a landfill undergoes biological decomposition in the following phases. Now the phase 1 is waste in landfill, which is biodegradable. Phase 2, aerobic bacteria thrive, temperature rises and oxygen is used up. Phase 3, anaerobic bacteria thrive, CO2, H2 and CH4 evolve. Methanogenic activity, now that is methane production by organic decomposition, stabilizes. Phase 4. Organic matter completely decomposed, the system returns to aerobic state. Advantages and disadvantages of sanitary landfills. First, let us study advantages of sanitary landfills. Now, it is very economical method if land is available. The initial investment is low compared to other disposal methods. No additional treatment is required. A landfill can receive all kinds of waste. The land can be reclaimed for use as playground, parking lot, golf courses, etc. Now let us study disadvantages of sanitary landfills. In highly populated areas, suitable land may not be available and transport to a suitable place will add to the expense. Proper methods need to be employed or the result may just form an open dump, which is dangerous. Periodic maintenance will be required for many years. Decomposition of waste may produce gases like methane, etc., which may become a nuisance. Composting. Composting means putting the waste organic matter to decay so that it can be used for fertilizing the agricultural land. Method of preparing compost. A trench of about 5 meter long, 1.5 meter wide and 1.5 meter deep is dug. A layer of well-mixed refuse and waste is spread in it for about 30 centimeter thickness. This layer is fully wetted with a watery mixture of cow dung and some mud. A second layer of mixed refuse is spread over the first layer till the heap rises to project above the ground level by about half a meter. This setup is left as such for about 3 months. Then the trench is opened, its material is taken out and rearranged in conical heaps and covered by earth. About 50 to 60 days later, the mass called compost is ready for application in the cultivation fields or in garden flower beds, etc. Effluent treatment. Effluents that are discharged from industries contain both organic and inorganic substances. Hence, the treatment is done in such a way that useful waste can be recovered at the same time. Methods of treatment. Number 1. Primary treatment. Large floating solids are removed, for example wood, plastic, by gravity settlement and screening. Number 2. Secondary treatment. Organic matter like sewage sludge is removed by oxidation or by precipitation. Chemical coagulants like potash alum are sometimes added to quicken the sedimentation process. Now number 3, tertiary treatment. This tertiary treatment is used when the effluent is being used for irrigation or for recycling. The water is passed through clear quartz tubes that are exposed to intense ultraviolet light. All pathogens are thus fully destroyed. Nitrate and phosphate levels are further reduced in the tertiary treatment to prevent eutrophication when the water is released into the water bodies. Purification of water for consumption. Now students, purification of water involves 4 steps. Number 1 is aeration, which is unwanted gases are removed by bubbling air through the water. Second step is removal of hardness. By addition of lime and soda ash, which is sodium carbonate, soluble calcium and magnesium salts are removed to precipitate. Now the third is settling tanks and filtration. Suspended and heavy particles are removed. Fourth is sterilisation. Now 1.49 of chlorine is added per centimeter cube of water to kill germs. Incineration. Incineration is disposal of waste by burning. Incineration serves 3 main purposes. One is to reduce the volume of waste. Second, reduce weight of the waste. Third, renders toxic waste into less toxic or even non-toxic waste. Precautions. Incineration should be carried out at a very high temperatures. Should be equipped with pollution control devices, which is very important for our nature. Incinerators should be installed away from residential areas. The leftover after incineration contains about 25% of waste residue as an ash. The ash should be deposited in landfills. Advantages of incineration. The ash leftover occupies much less landfill space. The residual bottom ash can be used for the recovery of some metals in it. Electricity can be generated from the heat released during burning. Vermiculture. Natural decomposition by aerobic bacteria soon depletes the oxygen and anaerobic bacteria start thriving. This slows down the decay of organic waste and emits foul-smelling gases. The earthworm's gut provides an ideal breeding home for aerobic bacteria. As the worm ingests the soil, The bacteria in its gut decompose the organic content of the soil, and the soil that is then excreted through the anus of the earthworm becomes manure, known as vermicastings. Vermicastings are highly enriched biofertilizer which contain a large number of microbes. The burrowing action of the earthworm also aerates the soil. Vermicastings also contain hundreds of tiny earthworm cocoons which hatch within a month and add to the earthworm population already in the soil. Importance of vermiculture. The degradation of organic waste by earthworm consumption is called vermiculture. Vermiculture or vermicomposting is eco-friendly, less expensive, and beneficial in the long run. The most useful feature of this technique is that it combines soil processing with waste processing. When biodegradable waste are applied to a soil containing earthworms in the form of a mulch, the decay starts almost immediately. Earthworms can thus be used very effectively to restore the fertility of degraded soils as well as process organic waste.